Well, now we're going to deal with compound inequalities. And so we have a combination of inequalities linked together by the word or. And the goal is to isolate m in each case and then graph. So we're going to solve by isolating m and then we're going to graph. So we'll undo this multiplication with division, and the 6's divide out, and we get m greater than or equal to, and negative 24 divided by 6 is negative 4, or, and now for the next one we'll undo addition with subtraction, or subtraction with addition, so I'll add 7, and we isolate m and get, let's see, negative 12 plus 7 is negative 5. So there's our solutions. Now we'll graph. And here we are at negative 5, and we'll put an open circle there since there's no equal sign associated with that inequality. And it says m is everything to the left of that. Okay, so there we go, m. And now m is greater than or equal to 4, so hash mark it, or negative 4. By the way, this should be negative 5. And we want a solid circle here because an equal sign is associated with the inequality and everything to the right. So there's our graph in interval notation. We have negative infinity to negative 5, parenthesis, union with, bracket, negative 4 to infinity. And there's our solution in interval notation. Well, here's another compound inequality to solve and graph. And the key word here is and rather than or as in our previous one. So this is a conjunction. So in other words, both of these inequalities have to be solved. A solution must lie in here and in here. So let's get started. Our goal is to isolate the variables. So I guess we'll add 6 to both sides, and we get v is greater than or equal to 6. And in this case, we'll divide both sides by 2. And so we get v is greater than, and 2 goes into 4 twice. 2. So now let's graph. And for the first one, we'll make a hash sign at 6, solid circle, and v is the variable and everything to the right. For the next one, we'll graph that, and 2 is down here. We'll put an open circle there and everything to the right. So now, looking at these two graphs, what's the smallest point that satisfies both of these inequalities? Well, it is 6. Because 6 is shaded here, it's also shaded here. But all values less than 6 are only shaded on this line, not on that. So the solution is 6 is greater than or equal to, beg your pardon, v is greater than or equal to 6. Notice with the single inequality, the variable is always on the left. Anyhow, there's our solution, and oh yes, in interval notation that would be 6 to infinity. Bracket here, parenthesis there. So there we go. And there's our, well, I guess our graphs, aren't they? But the actual graph that indicates the solution is right there. Well, here we have our third compound inequality to master. Solve and graph. But the word we have to deal with now is or, which means the solution can be in one interval or another. It doesn't have to be in both. So let's go ahead and solve away. So let's see. Let's isolate the term with the variable in it, and then isolate the variables. So our first task is to get rid of this 8 here. So I'll subtract 8 and subtract 8. And also let's subtract 3n, minus 3n and minus 3n. And when we do that, what we get is n, and the 8's add out is less than, and I have negative 6 and negative 8 is negative 14. So that's done. Or, this time around, let's add 8. So the 8's add out. Add 8. And let's subtract 9n. So we get all the n's on the left. And when we do that, I guess we get n is greater than or equal to, and 9 plus 8 is 17. 9n's added out, the 8's added out. So now let's go ahead and graph that. And here we are at, by the way, this is n, negative 14. We've got an open circle and everything to the left. And hash mark at 17, closed circle because of the equal sign, and everything to the right. And notice a solution can live in this interval, left of negative 14, or this interval on the right of 17 or to its right, but not in both at the same time. So anyhow, in interval notation, the solution is negative infinity to negative 14, parenthesis, union with, bracket, 17, infinity, and parenthesis. And there's our solution, there's our graph. And okay, did it.